Hello students, in this class I'm going to show you how to factor some polynomials. This is factoring techniques part 2. The first one we're going to start with is called the GCF, the greatest common factor. So basically whenever you see a binomial, trinomial, even a polynomial with 4 terms, we're going to ask the question, what is the biggest number that divides all terms? So here, for example, 6 divides everything, so we're going to say that the greatest common factor here is 6, because 6 divides 6 and 6 divides 24. Also, notice how they both have at least x to the third power in common. So all of these terms, or these two terms, are divisible by x to the third power. So we could make that be part of the greatest common factor. Oops, x to the third power. And so factoring out the greatest common factor would mean to take this out and see what we need to multiply that by to get the original expression. So 6 times 1 makes 6. X to the third power times x to the second makes x to the fifth. Then 24 divided by 6 is 4, so we need a negative 4 here. And because we factor out the x cubed, we leave it as just a negative 4. And one way you could check if you did it right is distribute, multiply, and you should get the original expression. But this one is correct. Now, whenever you factor something, you always ask the question, can we factor any more? So this is it. This is how you factor out the greatest common factor here, but because we could recognize that this is the difference of two squares here, we go ahead and factor this a little more. This is x plus 2 times x minus 2, and this will be the complete factorization of this binomial. So always ask the question, can we factor any more? And if you can, go ahead and do so. The next polynomial, the next trinomial, we're going to find the greatest common factor. Here, the greatest common factor, because I like to start with a positive number in front. Let's go ahead and factor out the negative. And they all have at least one x, so let's see if this works out. So we have negative x is going to be the greatest common factor, and we're going to get 2x squared plus 5x, minus 5x, because a negative times a negative makes that positive here, minus plus 12, yes. Okay, now this is a trinomial, and with the trinomial with a leading coefficient of 2, we're going to try to factor this anymore. I'm not sure if it factors, but if it does, we will finish it. If it doesn't, we leave it like this. But this is how you do the greatest common factor. We factor out the negative x. And so now let's see. If you remember the way I show you how to factor this, I'll do it on the side, is we multiply the first and the last number, and we get x squared minus 8x plus 24. And 24, what numbers multiply to 24 is going to be 1 times 24, 2 times 12, 3 times 8. Oh, I don't know where I got this 8 from. Sorry about that. It's supposed to be 5. My bad. Okay. So I realized that because I remembered I had a 5 there. And if you combine 3 and 8, we do get negative 5. However, I don't think it's going to factor, but let's keep trying. 4 times 6 makes also 24, and that's about it. So if anything works to factor this out is 3 and 8, but it doesn't work because we would have to have either both negatives or both positives, and there's no way we could make negative 5. So I guess this is not factorable anymore, so this would be the complete solution. Okay, so this is the fifth way, or the fifth technique in factoring, is the greatest common factor. Let's go ahead and put a little note on this one. And that note should say, whenever you're trying to find, or whenever you're trying to factor a trinomial, you should always start with the greatest common factor. Ask yourself, is there anything that divides all of the terms? And if it does, start with this one. Always start with the greatest common factor, the GCF. In any factoring problem, we always start with this. It's the best way to do it. It's not necessarily that you have to do it, but it's better if you do it. It's going to save you space. It's going to save you time. And so let's move into the sixth way of doing this, which is factoring by grouping. In all of the previous techniques, we use, or we had originally a trinomial or a binomial. So the minute you see 4, 5, or 6 terms, we're going to try to do this by grouping. And the way grouping works is we're going to group the first 2 terms like this. We're going to group the next 2 terms like this. But if you leave it like this, it's going to look like it's multiplication. We didn't have multiplication, so we need to put a plus sign. So we're going to group the first 2 terms and group the next 2 terms. So the next step we need to do is we need to find the GCF each group. We're going to try to factor the greatest common factor in each group. When we do that, notice on the first group, they both have an x squared in common. And so x squared times x makes x cubed. X squared times negative 6 makes negative 6x squared. And let me go ahead and color code this so you can see what's going to happen here. So x minus 6. Alrighty. Now let's go ahead and factor out the second group. What is the greatest common factor on the second group? They're both divisible by 5. Now please notice that since I have a positive, a negative, and a positive, I like to factor out the negative. I'm going to factor out the negative so that we could end up with this. X minus 6. X minus 6. I'm trying to color code this right here because whenever factoring by grouping works, the inside of the parentheses should be the same in both excuse me, in both terms. Notice how we have an x minus 6 and an x minus 6 on both. And so that becomes a common term to both of these. They both have the same term. So what we're going to do next is we're going to factor the common term. And so this term right here would be x minus 6, or this factor, I should say the common factor. Okay, so because x minus 6 is common to both of them, I'm going to factor it out. And what's going to be left, we're going to have an x squared here, and we're going to have a negative 5. And so this binomial, this this polynomial with 4 terms factors out into x minus 6 and x squared minus 5. Okay, example number 2 of factoring by grouping. Let's try to follow those same steps and see what happens on this one. So first thing I want to do is I'm going to group them like so. We're going to find the greatest common factor. You know, one of the things that I should have done before doing this is use what I told you up here, which says that we should always start with the greatest common factor. I just realized that because I noticed that all of them have at least an x squared. So let's go ahead and let's go back up and use what I told you to do before, which is factor out the greatest common factor here. And the greatest common factor here is x to the second. And we're going to factor out an x to the second, and it's going to give us 2x cubed plus 6x to the second minus x minus 3. Okay. And so if you didn't see it, you can still get it done. It's going to be a little different. But if you did not see that you could factor out the greatest common factor, then you can still do it. But let's go ahead and do it right here. Now, to factor by grouping, let's pretend that the new problem is this now. 2x cubed plus 6x squared minus x minus 3. And let's go ahead and do factoring by grouping on the side, and then we just put the solution down here. And so let's group. If we group like this, now we factor out the greatest common factor in each group, right? That will be step 2. Factor out the greatest common factor in each group. Both of these are divisible by 2, and they both have an x squared. So we end up with an x here, and then plus 3. Notice how on the next parentheses we have a negative x minus 3. So the only thing they have in common right now is a negative. So we could factor out a negative 1, and we get an x plus 3. Because factoring by grouping, if it works, we're gonna get this common factor is gonna be common to both of them, and it has to be exactly the same. So what we do in the next step is we factor out the common factor. So we're gonna get x plus 3, and then we're gonna bring this 2x squared here, and this negative 1 here. And so this polynomial here, this polynomial with 4 terms factors into this. So I'm going to just go ahead and write it down here. So we know our answer is going to have an x squared. And then this polynomial with 4 terms factors into x plus 3 times 2x squared minus 1. And we can't factor this anymore. If we could, we factor it one more time and we write the answer down here. But this here is the solution to this factorization problem. Please review this. Maybe watch some more videos on how to factor by grouping. But this is the way it's done. And the last type, or the last technique on how to factor polynomials, is what we call the quadratic form. So if you remember, quadratic functions look like this, or quadratic trinomials, they look like this. They look like x squared plus bx plus c. So an example of it could be, for example, x squared plus 4x minus 12. That could be an example of it. Actually, I left the previous form on, but anyway. So this is an example of a polynomial that is factorable. It's a quadratic one. How do we know it's quadratic? Because the exponent, the highest exponent, is a 2. But notice the relationship between the exponents right here. The exponent on the x is 1, and the exponent on the first term here is an x squared. So the exponent was from 1 to 2. So every time we see something that has that shape, that form, we could treat it the same way and factor it the same way. For example, if you were to see something that had an x to the 4th plus 4x squared minus 12, we factor it exactly the same way. If we had something that went x to the 6th plus 4x to the 3rd minus 12, we still factor it using the same idea. And so the trick here is recognizing this number. This exponent times 2 gives us 4. This exponent times 2 gives us 6. And anything, as long as we have something like that. So even a 10 here and a 5 here, we could still treat these polynomials the same way we treated this ones. So to factor example number 5 here, we're going to compare it to x squared plus 8x minus 20. How would you factor x squared plus 8x minus 20? You would factor it like this. You would find two numbers and multiply to negative 20. First of all, we need x times x, positive 10, and negative 2. Positive 10 times negative 2 makes 20, and positive 10 minus 2 makes 8. Sorry about that. And so this is the way we factor this out. So here we're going to factor it almost the same way. But now instead of x times x giving us x squared, now we need an x squared times an x squared to get an x to the 4th. But the numbers are going to stay the same. It's going to be pretty much positive 10 and negative 2. If you distribute and combine like terms, you figure out you get this back, so that tells us that that factorization is correct. Now you always ask the question if you could factor any more, and if you remember the sum of squares, even something like this is not factorable. This is not factorable anymore, so this here is the solution. If we could factor more, you go ahead and factor more. So same thing on example number 6, we're gonna compare it to, what would that compare to? We would compare it to x squared plus x minus 12. And the way to factor x squared minus, or plus x minus 12 would be x plus 4 and x minus 3. And so this one is going to factor then, example 6 is going to factor into x squared times x squared, because that's how we get x to the 4th, and then positive 4 and negative 3. And if you remember that the difference of squares doesn't factor, so that can be factored no more. Neither could this one, so this would be the solution. So always try to look for if you multiply this exponent by 2 and you get that exponent, that's what we call the quadratic form. Okay, so like I said, even something with like a 5 and a 10 here, that would still be factorable, the same idea, using the same form. Keep practicing on how to factor, and then keep watching videos, or watch this video again if you need more help on it.